Hey there, Mr. Wilford here. I just wanted to go through Chapter 7, Section 1 with you. And this one's all about exponential functions, growth, and decay. And this starts a new chapter. And what we're doing is we're looking at something called an exponential function. And this is really kind of a new equation that we haven't seen before. We've done a lot of things with polynomials and different kinds of equations where our variable x is really the base. It's we take x to the power of a number, like x squared, x cubed, things like that. Um, and this is a little bit different now. What we do is we actually put the variable x as a power. So we have a function that looks like this. F of x equals, or remember, f of x is really like y, equals b, where b is some number, to the power of x, where x is the variable. And we call the b a base, and that's going to be a constant. And then our exponent x is the variable. And so it looks something like this right here. B is greater than 0 and b is not equal to 1. And we have an example here. The parent function, which is the most basic kind of function or equation that we look at. Again, y equals 2 to the power of x. If we graph that, the graph actually looks like this. It actually almost is horizontal here along the x-axis, and then it shoots up very rapidly. And we say that the domain is all real numbers because we can plug in any number for x, and the range is y is greater than 0. And what that means is that our range is not equal to 0, but it's equal to everything above 0 or greater than 0. We have what's called an asymptote, and that is a line. In this case, it's actually the x-axis. It's this green line down here. And it's an asymptote really is a line. It's kind of a guideline where the graph gets really, really close to it, but never actually crosses it. So in this case, the x-axis is the asymptote. If you take a look at a function that looks like this, and really all that's changing here is we're taking a number a times b to the power of x. When a is greater than 0, in other words, when it's positive, we have what's called a growth function, exponential growth. And so as you read the graph from left to right, it increases very rapidly. If b, the base here, if b is greater than 1, we have a growth function. If b is between 0 and 1, then we have a decay function. And so that would be an example like this. As we read the graph left to right, it actually is going down very rapidly. And then it kind of goes horizontal to the right. And again, you should use your graphing calculator to graph these functions here. Just be careful how you plug them in. A lot of good types of problems that you can do with these kinds of functions, these kinds of equations. They're used a lot in different science examples, or like banks will use exponential equations and things like that. So we'll talk about a lot of different application problems with these as well. So this is our basic formula here when we're talking about different kinds of increases or decreases in a rate. And you notice here that we have a plus and minus, and that means that if the rate is increasing, if it's going up in value, then we use plus. If it's going down in value, then we use minus. This example here is just showing that there's a guitar. We have an initial amount, an initial value, which is our A, and it's increasing in value at 14%. So we put in 0.14 and into the formula, and then we can calculate out the final amount that it would be worth. In this example, you buy a truck, for example, but this time it's decreasing at 9.5%. So make sure you take a look at how you plug that into this problem here. Again, you can look at the graph to make predictions and go from there. If you have any questions, please let me know. Thanks.